Hey, what's up, Marauders? This is section 4.3, acid and base reactions. We'll spend a whole lot of time later in the year about acids and bases. We'll do 2 or 3 chapters devoted just to acid-base reactions. So this section 4.3 is just kind of an introduction to acids and bases and some of the really simple reactions that they'll undergo. We'll learn a lot more about them later. So for a definition for right now, we'll just say that acids ionize to produce hydrogen ions. Hydrogen ions are also sometimes called protons. If you look at hydrogen, and we look at how many protons, neutrons, and electrons it has. So from the periodic table, hydrogen has 1 proton, its atomic number is 1. Neutrons, 0 for most hydrogen atoms. Its mass number is really close to just 1. And then electrons would be equal, so it would also be 1. If you make it into a hydrogen ion with a +1 charge, okay, so now the protons haven't changed, it's still 1. The neutrons, still 0, that hasn't changed. But the electrons has changed. It actually lost an electron to get the +1 charge, so it has 0 electrons. So the hydrogen ion with a +1 charge is really just the same as a proton. So we use those two terms kind of interchangeably. So what do acids do? Well, all acids are going to start their formula with hydrogen because they need that proton to donate. And so it's one way to recognize that something is an acid is if its formula starts with hydrogen. So HCl, hydrochloric acid, when it goes into water, it's going to produce hydrogen ions and it's going to produce chloride ions. So it increases the proton concentration in the solution and therefore is an acid. H2SO4, sulfuric acid, is going to do the same thing. It's going to donate its hydrogens. This is called a diprotic acid. It has 2 hydrogens that can be donated to the solution. So it's going to make 2 hydrogen ions. And then it's going to make the SO4 with a -2 charge. So there's diprotic acids that have 2 hydrogens. There's also just polyprotic acids, which have 2 or more hydrogens in them. And then HCl would be monoprotic because it has just 1 hydrogen. So bases are, we know, the opposite of acids. And so what do bases do? Well, bases, we can say they accept hydrogen ions and they produce hydroxide ions in water. Okay. So the easiest bases to learn are the ones that actually contain hydroxide. So all of your metal hydroxides are basic solutions, and any of those that dissolve in water or are soluble in water are going to produce the sodium ions and the hydroxide ions. So it's just dissolving, it's just breaking apart into sodium and hydroxide. And since this increases the concentration of hydroxide, OH- in the solution, it's considered a base. NH3 ammonia is also a base. It works in a little bit different way. The way this increases the hydroxide concentration is by taking a hydrogen away from the water. So when ammonia is put into water, it forms the ammonium ion, NH4, with a +1 charge. And those will be aqueous. And when water loses 1 hydrogen, when it loses 1 proton, so that's a proton being transferred from the water over here to the ammonia to form ammonium, then what's left here is hydroxide. All right, so 2 different types of bases. We'll be working in this chapter mainly with the ones containing hydroxide, but you'll see a lot of other types of bases later in the year when we talk more about acids and bases. There are 7 strong acids, and you should remember these 7 strong acids. These are ones that completely ionize in solution. So when you put hydrochloric acid into a solution, 100% of it is present as hydrogen ions and chloride ions. Hydrogen ions and chloride ions. 100% of it breaks apart into these parts. If you have a weak acid would be like HF. I think we talked about this earlier. When HF is dissolved in water, it produces a few hydrogen ions and a few fluoride ions, but the majority of it, 99% of it, actually stays together as HF molecules. Okay, so strong acid completely dissociates, makes a lot of hydrogen ions and whatever the anion is. Weak acids, when they dissolve in water, they produce a few ions. It'd be a weak electrolyte, but the majority actually stays together as molecules. So there's 7 strong acids. You should know these: sulfuric acid, nitric, hydrochloric, hydrobromic, hydroiodic, chloric and perchloric acid. Those are all the strong ones. And then everything else, there's hundreds of others, everything else is a weak acid. Acids and bases are opposite of each other, and so when they react together, they produce what's called a neutralization reaction. They balance each other out. And so we'll look at an example here, but basically neutralization reactions are always going to have an acid reacting with a base, they're opposites, and they're going to produce salt and water. All right, so in this example right here, these look pretty much like the double replacement or the precipitation reactions that we looked at in the last section. So the cation from here, which is hydrogen, is going to pair with the anion from here, which is hydroxide. So we have hydrogen ions and hydroxide ions, and so they're going to come together to make HOH, or more commonly we write that out as H2O. And then the sodium is going to pair with the chloride. Okay, so that's going to make sodium chloride, NaCl. And so this is an example of how an acid and a base produce salt and water. This is a soluble salt, so we can write AQ after it. And then this is water. Water's not really aqueous because it's just water itself, so it's considered a liquid when we're writing the state symbol next to it. And so if I want to do a ionic and then net ionic equation for this reaction, hydrochloric acid, it's a strong acid. Since it's a strong acid, it completely dissociates, so really it's present as hydrogen ions and chloride ions. And then sodium hydroxide is a strong base, so really it's present as sodium ions and hydroxide ions in a solution. And then over here on the product side, sodium chloride, very soluble because it contains an alkali metal, so sodium ions and chloride ions. And then H2O is a liquid, it stays together. Water doesn't dissociate to a large extent, so that would be remaining as a liquid. So that'd be my ionic equation, my complete ionic equation. And then if I want to see what I can cancel out, we have sodium on each side and we have chloride on each side. So those can cancel out, and then what's really happening is that the hydrogens from the acid are reacting with the hydroxides from the base, and they're making water. So this would be my net ionic equation, is that just hydrogens are reacting with hydroxides to make water. Here's one more example. So again, it's an acid, H2SO4, with a base, KOH. And so just like before, the hydrogens pair with the hydroxides. So over here we have two hydrogens and only one hydroxide, but it doesn't matter, right? We're thinking about the charge of each ion. So hydrogen's a +1 charge, hydroxide's a -1, so it still makes water, which is a liquid. Okay, don't worry about how many of them you have. We can go back and balance it at the end. And then the potassium is going to pair with the sulfate. So potassium is a +1 charge, sulfate is a -2 charge. So when we put these together, the cation should go first and the anion second. So it's going to be K2SO4. We need two potassiums to pair up with each sulfate. That's going to be aqueous. We have an alkali metal involved, so we know it's going to be very soluble. All right, now we can write out the whole thing as an ionic equation. So we have hydrogen ions, we have sulfate ions, potassium hydroxide, so that's potassium ions, and hydroxide ions. We have water, which stays together as a liquid, and then potassium sulfate, potassium ions, and sulfate ions. All right, canceling out anything that's on both sides. We have potassium on both sides, sulfate on each side. So those are spectators. So we have actually the same thing taking place. Hydrogen reacting with hydroxide to make water. This example is slightly different. This one is an acid and a base reaction, so it's still a neutralization reaction, but this one's going to produce carbon dioxide. Okay, so when an acid reacts with carbonate ions or bicarbonate, then the product is going to be carbon dioxide. Carbon dioxide will be produced when the carbonate or the bicarbonate ion reacts. You guys have seen this one before. This would be a reaction like vinegar and baking soda. So vinegar is a type of acid, acetic acid, and then baking soda is sodium bicarbonate, so it contains the bicarbonate ion. And then the gas bubbles that you see produced when baking soda and vinegar react together, those are carbon dioxide bubbles. So you guys have all seen reactions like this before. Now you're going to know how to write the equations for it. You're going to know what's actually taking place. So we'll start with this. So hydrogen pairs with the carbonate. And so that'll make, so CO3 has a -2 charge, hydrogen has a +1 charge. So that'll make H2CO3. And then this is going to be sodium pairing with the chloride. So that's going to make sodium chloride, NaCl. So the way that this produces carbon dioxide is that there's going to be a second step to this reaction, and that this is carbonic acid. And carbonic acid, H2CO3, is going to break down on its own, and it's going to produce carbon dioxide, which is a gas, and water. Okay, so this carbonic acid that's formed in the first step is going to react in the second step to produce carbon dioxide and water. So this is something you want to watch for, or that you might see in labs, and you might recognize when you see the gas bubbles forming with carbonate or bicarbonate ions. It's probably because it formed carbonic acid, and then the carbonic acid breaks down into carbon dioxide and water. So I want to put all this together. I could write out the whole equation, so it'd be HCl plus NaCO3. And then instead of writing carbonic acid, I'm going to put these two products that it breaks down into, CO2, which is the gas, plus H2O, which is the liquid, and then sodium chloride. And so we'll see this reaction or reactions like this in the lab a couple times, and probably on other assignments as well.